Sir, good morning, sir. We can start the session, sir.
My video is on. So you are able to hear me? Okay. So what should I do now? Are there other audience?
Yes, sir. We can hear you, sir.
Do I receive those queries? Okay. Then if I write on my screen, are you able to see my screen? Introduction to graph algorithm. Because if I write, oh, I'm able to see. What is it? YouTube. Oh, okay, fine. Going on, fine. Everything is okay. All the time. I'll share the screen. Share the screen. Screen share. Screen, start broadcast. 1 minute. Zoom. இப்போ நீங்க broadcast பண்ணுங்க. இது screen போலாம். இது screen இல்ல. இது இதுல போட்டுமா? இல்ல அதுல எழுத முடியாது. எங்க இது அந்த ஸ்லைட் வச்சிருக்கீங்க? இல்ல ஸ்லைட் இல்ல. இந்த இது நோட் பேட் இருந்ததுன்னா நான் வந்து அதுல சும்மா அப்படியே எழுதுவேன். பேஜ் பை பேஜ் இதுல எழுதிடுறேன். ஐ கேன் ரைட். One second. Where is the 99%? Okay. Okay. Can you ask someone to unmute and ask them to speak? I will. Also, you have to check the audio whether we are getting the feed from them. Okay. So I will first check whether they are getting the audio.
Yes, sir. We are getting the audio, sir.
You are getting the audio. All the students. Can some student ask me a query? I am checking whether I am able to reach you. Can some student unmute and ask a question? Hello?
Sir, can you hear me, sir?
Yes.
But some echo is there.
Echo, I will cut the phone. Okay. Yes. Are you able to hear me? Hello?
Yes, sir, we are able to hear you.
Okay, perfect. In that case, let us start the session. Welcome to Graph Algorithms session. So, since there is a week ahead for your exam, some of you may have some queries on the various topics. So, if you have any queries, let me know. I will give oral explanation as well as in case you want things to be written, I have the screen in which I will write it out. Any questions? Sudha, are you able to hear me?
Yes, sir, we are able to hear you.
Okay. So then I will wait for the questions. If there are no specific questions, it's fine.
Okay, sir.
Good morning, sir.
Good morning.
Am I audible? This is
Yeah.
this is Pramila.
Okay.
Actually, I wanted to join the last what is that live session, but I could not. I have not received any notification.
Okay.
So, is it possible to explain Bellman-Ford algorithm for single source shortest path with the examples? Theory part I have understood. One example, if it's possible.
The example will become difficult to explain because there are a lot of metrics and then the whole thing is to be worked out. But yeah,
Okay.
1 second. Yeah, 1 second. Just stay 1 second. There's one person who is talking with me now. What is it? Okay. Okay. So the example requires that row by row updating of a matrix. Okay. So what we are trying to do is that we are trying to find, we are minimizing, no? There are several entries and you have to find the minimum in that and then fill the table. That is the reason why working out one example is not only going to take time, it will require space. That's the reason why we didn't do that.
Maybe one iteration may be sufficient, sir.
One iteration. That means now I need a graph and the Bellman and Ford. I require that the notation that is used. Actually, I'm in Chennai, so I wait a minute. Let's see how I can help. Sudha madam.
Sir?
Is it possible that I work it out and then that can be that screen can be broadcast to people later in
Yes, sir, that is possible.
Oh, okay. So so what I will do is the following. I will work out one example because online working out and referring to that notation and the input. See, what I need is that an input graph, its adjacency representation, then the algorithm steps execution on 1 or 2 iteration I have to show, right? What I will do is that I will work it out physically, one example, and then upload it. Okay? I will do that.
Yes, sir.
Soon.
Yes. Thank you so much.
Exam is on 19th only, right? 19th or 21st?
21st.
Okay, you are taking 21st. Very good. No, don't worry. I will do it right by today or tomorrow. It will be broadcast to all so that you will have an access to my worked out example. Okay?
Okay, sir. Thank you, sir.
Surely I will do that. I mean, if that helps, why not? No issues at all. Okay? Thanks for that question, and this might perhaps help several others also. So we can as well. Yeah. Any other queries from anybody else? Sudha, we can talk to Surbi. Surbi had that examples, right? So we can make a printout of one of the running examples and then see the. It doesn't matter. I will come and do it. I'll come Sunday and then tomorrow I'll finish it and then hand it over so that it can be broadcast.
Yes, sir.
So any other queries that anyone has on the contents and so what I will do is 5 minutes. I will give probably a quick overview. Basically, we want to do about algorithms. Every algorithm will have certain computational steps. By complexity, time complexity, we mean the number of instructions. So we have to count how many instructions are executed for an input of certain size. Let us say f graph means n vertices and m edges. So we will specify the input size. For that input size, how many instruction count and the maximum instruction count. This is called the worst case complexity. For every algorithm, worst case complexity is the key factor that will comment about its efficiency. So how much time it takes, we will know when we know how many instructions it executes. Because each operation consumes time. When you do so many operations, it is going to take so much time. So to express that in a more mathematically simpler and complex way, we have big O notation and theta notation. The exact value could be something like 7n square minus 8n plus 9 or something like that, but we will simply say that as theta n square. You can also say it as ON square. This is much simpler way of understanding the exact complexity. Sometimes we may not get the exact complexity figure, but we will say in simple terms, ON square, it is quadratic algorithm, it is order n square, it is theta n square. These kind of a comment in order to make, you must know how, when a function that is looking complicated can be expressed in terms of some simple things like this. So we have the definition. You can use calculus, you can use exact summation bounds and so on, and come to these kind of conclusions. For example, if you take f of n by g of n, and if this goes to a constant that is not equal to 0, it should be non-zero, right? As n goes to infinity, then f of n is theta g of n. Now you can see why 7n square minus 8n plus 9 is order of theta n square. You do this and let n go to infinity. you can see that this is 7 minus 8 by n plus 9 by n square. As n goes to infinity, this will go to 0, this will go to 0. Therefore, this will go to just 7. And 7 is not equal to 0. Therefore, we conclude that they are the same order. Their growth rate are same. Therefore, 7n square minus 8n plus 9 is theta n square. This kind of a conclusion we get by using some simple calculus. The other way is getting a bound. You see that f of n is theta g of n if there is a constant C1 gn is less than or equal to f of n is less than or equal to C2 times g of n. That way, you can see that 7n square minus 8n plus 9, okay, is less than or equal to, you can less than or equal to 24n square. That is because this is less than or equal to 7n square plus 8n square plus 9n square. Therefore, I have one constant. The other one, you can simply say, let's say 4n square. 4n square is less than or equal to 7n square minus 8n plus 9 is less than or equal to 24n square. Therefore, this function 7n square minus 8n plus 9 is theta n square. This function. So you can use inequalities, you can use calculus, and you can use any one of these techniques to check whether it is. So, for example, if you look at 3 power n is not theta 2 power n. How do you show this? You take 3 power n by 2 power n, and this is equal to 3 by 2 power n is equal to 1.5 power n. So as n goes to infinity, this goes to infinity. It should go to a constant. It cannot go on increasing. In that case, it will not be of the order. You cannot bound it. So you can see that as n goes to infinity, therefore, you conclude that 3 power n is not theta 2 power n. So these kind of simple ideas and questions, you should be prepared. And then we always talk of, when it comes to graph algorithm, the shortest path algorithm, single source shortest path algorithm. Okay. This one, you have Dijkstra's algorithm, you have Bellman and Ford algorithm. And then you have the idea based on matrix representation. Based on this matrix representation, how you would compute it. Then you have all pair shortest path, all pair shortest path problem. Okay. So here also you have Warshall's algorithm and couple of algorithms that we have discussed on all pair, Johnson's algorithm and so on. And everything you just have to work out or hand simulate an example. Okay, most of the textbook will have something, but what I will do is that since someone asked an example, I will work out one example of Bellman and Ford. This Bellman and Ford, this text, and then explain. Similar thing if you prepare. That's enough for the exam. Basically, you must know how the algorithm works. So you take an input and then work on and calculate. We will give only small example because in the exam you have to do the hand calculation. You won't be given some 10-node graph with 400 edges and stuffs like that. Okay. So simple graph will be given and we will ask certain questions. Okay. Spanning trees and shortest paths and so on. This all is the general shortest path, then spanning trees, then depth first search or breadth first search. With this, our discussion on the graph algorithm is compactly done. It's a 3-week program. So we have taken an introduction to what an algorithm is, then gave some basic ideas on path problems. Then we have discussed about the minimum spanning tree problem. And then we finally discussed how to find the depth first search and depth first search. In all of them, 1-mark questions and 2-mark questions, executing the algorithm on a small input and producing the result is what you have to do. So when there is a multiple choice question, we will give one right answer and obviously other wrong answers. When you calculate and then if you find it, then you will know what is the right answer. Therefore, to answer those multiple choice questions, you have to work out and you should know how the algorithm works. And once that is done, rest of them fall. So that's all. It's a basic overview. And if there are any further questions, let me know. If there are no further questions, it's perfectly all right. We will wind up the session and then you can always send a mail and then get in touch with me. Sudha madam,
Yes, sir. Yes, sir.
can we close the session if there are no further questions?
Sure, sir.
Yeah, there was only one query that I have already replied. I will circulate to you and then you can in turn post it and then the action
Sure, sir.
as a follow-up action can be taken. So if there are no further questions, we will wind up at this point.
Okay, sir, we can wind up.
So shall I close the session?
Yes, sir. Yes, sir.
Okay, I'm closing the session. Okay.